All right, let's actually begin. So, welcome to Math 212. Now, usually, you guys are lucky because up until, I don't know, 2 semesters ago, the class used to be 202, which is traditionally what people think of as Calc 2, but now we've made it a little bit more interesting. So we're going to be covering things that are traditionally in a Calculus 2 class, as well as a few things that are traditionally in a Calculus 3 class. So, hence the new name of the class, as you can see on your syllabus, is Calculus with Intro to Multivariable Calculus. Because, I guess we got too bored with teaching just single variable calculus. We're going to do multivariable calculus. We're actually going to get you started. So, my name is Jhevon. You can call me Jhevon, it's fine. And this is Math 212. So it's our Calculus 2. So make sure you're in the correct spot. That's not the class. So, that being said, let's actually start reading the syllabus together. Let's make sure we know the rules here. So, I'm teaching 2 sections of this class. So you are section GH, as you can see. This is Monday, Wednesday, 6740. This is the class website. That's actually already up. You can go there right now and you'll be able to see stuff there, although it's not fully populated yet. But you'll find an electronic version of the syllabus there, already there, as well as instructions on the homework, and I'll get to that. Where all these links will be clickable, so that'll be a little bit nicer. So that's the class webpage, so you're going to be going there a lot. That's my name, that's my email. If you ever need to contact me at that email, because I've had trouble with my CCNY email, which I don't want to get into. So these are my office hours. These times or by appointment. The tentative location for that office at the moment, because they're still shuffling people around, is NAC 1219, but that might be somewhere on the 8th floor. That might switch to somewhere on the 8th floor, so I'll keep you guys posted. So that's my website. That's a general website. If you go to that website, you'll also find a link to your class website, so that's it. This is Thomas Calculus is the textbook that we're using. Same textbook that was used in 201 last semester, and I think the semester before that. And that will actually send you a link to the book, but I'll talk a little bit more about that soon. This is the main math department website, because it's good for you to have it. And this is the math department's Math 212 website, which I'll be sending you there. Around finals week, I'll send you there, because they will post old, I can't even say old right now. So they're going to be posting sample finals there, which is going to help us for our practice, so I'll be sending you there towards the end of the semester. So, this is the syllabus, this is what we're covering. Calculator is not allowed, and in terms of the textbook, you don't have to purchase the textbook, but you do have to purchase online homework access, which I'll be talking about in a bit, although not much, because the instructions for accessing the online homework can be found here on the class webpage. So you go there, it'll tell you instructions on how to actually get the homework, so make sure you actually do that pretty soon, because homework is already up. Let me actually write that down. Homework is already up. So we have some homework sets due on February 7th. And it's mostly just review stuff, just reminding you some review from Calc 1, as well as the homework on the first couple sections. It's already posted, so you want to actually get access to the homework as soon as possible. Okay, so that's the typical grading chart. A+ starts at 97, I think. And as most of you know, at City College, the final is worth 40% of your grade in a math class, and the other 60 comes from class, and it comes in this form. So as you can see, we'll be doing quizzes, homework, participation, tests, and the final. Quizzes count for 10%. I'll give you a quiz every week, except the weeks where you have a test. We'll have 2 tests, and I'll tell you when those guys will show up. Homework, that's online, that's 5% participation. You get 5% participation. It's pretty much every time I come here, I'm going to take attendance, and I'm going to actually give you credit for that, so that's pretty cool. In-class tests, there are going to be 2. They're going to be non-cumulative. Together they make up 40%, so 20% for each test. And the final is 40%. That is cumulative. And for you guys, I'm writing the final. For the other section, the department is writing the final. But either case, I will be the one grading it. Moving on. So, usual makeup policy, I think here, you can't make up quizzes or homework. I will actually drop the 2 worst quizzes. And as for homework, I think I made a cutoff here of, I think I wrote it down here. Yes, I did. I meant to type it. But for homework, what I'll do, I'll actually have to update this, is if you get at least 85% on the homework, I'll automatically bump that up to 100%. So just in case you have technical issues, that'll be fine. I'll update that soon. Attendance policy, always show up, be on time. I'm actually giving you credit for it. Second of all, if you decide to be absent and you don't actually tell anybody, if you accumulate 5 unexcused absences, I kind of have to fail you, so don't let that happen. If you're late or absent, you need to let me know the reason and provide documentary proof whenever it shows up. More comments on work ethic, don't slack off. So, there's this age-old debate where students are always debating, what's harder, Calc 2 or Calc 3? And there was always a very debatable question. A lot of students will be like, you know what, I think Calc 2 was harder because it's way more like volume of stuff. We have a lot more things to cover, and a lot of people find Calc 3 harder because, oh, it's 3D and visualization and all that, and there's always this back and forth, what's harder? Let City College decide to put that to rest. Calc 2 is harder, for sure. No debate about it. This is the hardest class in the calculus sequence, without a doubt. There's no debate anymore, right? Because here we're kind of doing a lot of Calc 2 and the Calc 3. So we have both worlds here. Calc 1, no, Calc 1 is Calc 1, it's not really that bad. But yeah, Calc 2 has Calc 2 stuff and Calc 3 stuff in there, and Calc 3 will just have a few Calc 3 stuff at the end. So yeah, this class is the hardest one. Don't slack off. So the moment you realize you forget something, do not take it lightly, immediately go, just get really frantic with it and try to look up the answer right away and practice a bunch of problems. If you fall off for like a week in this class, it's all over. So just a warning there. It's going to be tough. It's going to be intense, but you guys can do it. Let that scare you. Very possible for you to do well. It's just that you have to give this class like respect. It's not. I mean, you can goof off in Calc 1 and still get an A. It's not going to happen here. Okay. So. Boom, homework, that's going to be online. Like I said, a few homework sections are already up and they're due about a week and a half from now. So there are 2 options to purchase the homework. The usual digital access is going to run you about $80, but I highly recommend that you go with the slightly more expensive option of $150, and you'll actually get a physical copy of the textbook as well. And this is the textbook that we use throughout the calculus sequence, so you're going to use it again in Calc 3. I think it's worth the extra $35 to get a physical copy. Like I said, quizzes every week. In terms of quizzes, it'll be in general, short answer, fill in the blank kind of thing, something that I can grade relatively quickly and get back to you, usually within a week after giving them. Tests are going to be like pretty much the full period, though. You have to show all your work, so you can't just write the answers. With quizzes, you're pretty much just going to write the answers on the quiz. The final is also long form. You have to show all your work, and I'll be grading you, giving you partial credit based on all the steps you do. Moving on. Prerequisites. I expect you to remember all the math you've ever done in the calculus sequence. So algebra, pre-calc, calc 1. I expect you to remember them. I have actually recorded lectures of my pre-calc and calc 1 classes. I actually taught pre-calc in spring 2019, and I taught calc 1 in fall of 2019. So these are actually links to the playlist, and like I said, if you go to the electronic version of the syllabus, this is clickable. If you go to the class website, so if you ever need to review anything, and you want to know, does Jhevon really expect us to know that? You can actually know, because Jhevon tells you exactly what he expects you to know. And I told all my pre-calc kids exactly what I expect them to know. And I told all my calc 1 kids exactly what I expect them to know. So you can go here to review, or just know, what does this Jhevon kid expect me to know anyway? That's a good resource. I'm going to teach this class on the basic assumption that you guys know certain things that, I don't know. If you came from another school, you probably don't know. Let's see. Do you know what that is?
1 over
Yeah, Jhevon expects you to know that. I don't expect you to know for the cosine inverse or the secant inverse or the cotangent inverse or any of that. Tangent and sine inverse though, I expect you to know their derivatives. Hence, I also expect you to know that the integral of this guy is going to give you that guy plus c, and the integral of this guy is going to give you that guy plus c. I expect you to know how to differentiate exponentials and logarithms. So like e to the u, what is that? d dx of e to the u.
u
Prime e to the u. What is d dx of ln u? Prime over. What is d dx of a to the x, where a is a constant? Jhevon expects you to know that. Right, so there are a bunch of things that I'm going to expect you to know. These you can find out what they are from there. Now, let's move on to the next section, blasphemies. It's a fun section. What was the last class about? Let's learn how to read time, kids. Yeah, that's enough. So let's talk about do-nots in this class. So there are certain things that I will think of as far beneath you. If you do any one of these things, I will give you a 0 for the problem that you do them in. Not going to read anything else. You're right. You could have the most brilliant mathematics. You could have solved Fermat's last theorem if at any point in that proof you make one of these mistakes, I'm going to give you 0 for that. Not be impressed. So 1, don't cancel across sum. And I don't want to spend too much time on this because I did spend a lot of time on these in the Calc 1 class. You can go watch that a little bit more. But this is if you have something like, okay, 2x plus 1 all over 2, and you try to cancel the 2's. Very legal. You do that, I give you 0. Not kosher. You cannot cancel across sums because of the plus sign up here. It also works for a minus sign. You can't actually do that. You can only cancel across multiplication or division. So there, that's okay to cancel. So that's this very bad, very wrong. 2, don't distribute powers across sums. So that's like if you have, if you see like x plus 2 all squared, and you tell me that's x squared plus 4. Very bad. No, that's not x squared plus 4. You cannot take the 2 and just attach it to each part. It's called distributing a power across a sum. Very common one that people often forget about is with radicals. So if you have this, and you say that that's x plus 2, that is very wrong. Because a radical is actually a power, right? That's x squared plus 4 to the 1/2. You cannot take that power and attach it to each part. That is very wrong. Do that, I will give you a 0. Another thing. Always self-explanatory. Don't divide by 0. I see people do it all the time, and they try to convince me that it has some sort of meaning. It is gibberish. Now, you guys are Calc 1 students, so you do know about limits, hopefully, but you, of course, understand that when your denominator is heading to 0, all sorts of things can happen. But in a limit, you never actually divide by 0. You just get close to divide by 0, right? You're approaching 0. What is this one? No. This does not exist. What is this one? What is this one? Jhevon expects you to know all that. Okay, so when you're almost dividing by 0, like a lot of crazy things can happen. You can get any answer under the sun. So you can't just say you end up with 2 over 0 as an answer to some problem. That, oh, that's infinity, or that's 0. No, it's meaningless. It's gibberish. It doesn't mean anything at all. That means you either made a mistake, or the problem you're looking at has no solution. You can't actually divide by 0 and get an answer. It doesn't make any sense. The closest we can get to doing that is with limits. But you can't actually plug in 0 in the denominator or anything. If you ever do that and tell me that it's some sort of answer, I will give you a 0. So don't do that. Other things not to do. Forget the product rule for derivatives. So if you are differentiating f of x times g of x, and you tell me that that's the derivative of f times the derivative of g, this one shakes. I don't know if all the others shake. So that's actually incorrect. Right? So if you're trying to differentiate, say, x times sine of x, and you tell me, oh, that's just 1 times cosine, of course, that is incorrect. The product rule says you have to differentiate one, leave the other, plus differentiate the other one, leave the first, and you're supposed to know to do that. It's also, you should not think that the derivative of a division is just differentiate the top, differentiate the bottom. That is incorrect. Right? There's a whole quotient rule. What does the quotient rule say? The derivative of f over g is
g prime times f over squared.
okay. Go again. 1, 2, 3, go.
Gf prime minus fg prime g squared.
Okay, that's correct. Of course, your g cannot be 0. So it's bottom times derivative, top minus top times derivative, bottom over the bottom squared. Another thing, whenever you remember a rule or ask you to regurgitate a rule, I expect you to state the entire rule. So if I say, oh, what is the quotient rule? And you only tell me the right side, you are wrong. If I say, what is the quotient rule? You have to tell me the entire equation. You have to tell me the derivative of this equals that. The equation is the quotient rule, not just the right side. So don't do that. Know the product rule, know the quotient rule. Also, you should be aware that integration is pretty much the same story. So you should know that if you're integrating a product of functions, that is not the same as just integrating each part. That's not true. This is wrong. So you can't actually do that. Okay? So if you had the integral of x times sine of x, it is not, or the integral of x be by itself.
Half x squared.
X squared over 2, or the integral of sine of x be by itself. Right, so you see how you integrate each piece? You always remember the plus c is another one. Like, I probably won't give you a 0, but I'll definitely deduct at least a point if you forget a plus c on an indefinite integral. So if you ever try that, that is incorrect. That is a 0 there. This integral, you haven't learned how to do it in Calc 1, at least not traditionally, and I never told my Calc 1 students how to do this, but we will learn how to do an integral like this on Wednesday. By Wednesday we'll know how to do that integral. How would you do this integral? Substitution. What would you substitute?
You substitute x squared u and take the derivative of it. Substitute
Okay.
that.
So you should know how to do that. Now, these two look almost like the same. Substitution works on this one, substitution does not work on that one. So when you're integrating products, it can get a little sketchy. In fact, that's going to be a general theme. You see, what makes Calc 1 so easy is that we can talk about like these general rules of thumbs, like the product rule, right? Which says that if I want to differentiate one function times another, it's that plus that, right? And that's a rule that in any situation where I have two functions multiplying each other, I can use that rule to differentiate them. Very straightforward. As long as you know that rule, and as long as you actually know the individual rules for differentiating the individual functions, you can differentiate the multiplication of any two functions. Things like that, as of now, don't work anymore. You can be in two very similar situations, and the way you deal with them are completely different, right? So there is going to be an art to Calc 2. There are going to be nuances to Calc 2. I'm going to give you a lot of rules, and I'm going to give you a lot of formulas, and I can only tell you guidelines for using them. I can't just say, oh, if you're in this situation, you always do that. Like, I can't really say that a lot of the time. And it will be the case where just one little thing can make a world of difference. Like, if you want to integrate that, what is that? E to the x plus c. You want to integrate that, what is that? Very small stroke of a pen. You just went from a very easy integral to an impossible integral. And I'm not just saying that it's impossible as a euphemism for saying it's really hard. I mean, it's impossible, right? Like, there is no function that you can think of, try, that when you take the derivative according to some derivative rule, you'll get e to the x squared as an answer. This guy has no antiderivative. It does not have any antiderivative in any of the functions that we understand from calculus, the 6 elementary functions, or any combinations of them with arithmetic. We cannot create the integral of that function. So you can go from an easy problem to an impossible problem pretty easily in Calc 2. Not so much in Calc 1. Like if you had to differentiate e to the x, and then something like, ooh, e to the x squared, chain rule, it's not a big deal. In Calculus 2, it's a big deal. Like, one little thing is gonna mess everything up, so you have to be very careful. Let's actually, this one grabs, let's try using this one. So you have to be careful with the rules here. So don't do that. Another mistake, I forgot what mistakes were. Was it 6? I can't remember. Okay, so another thing you don't want to do. You would recall that 1 over x dx is what? No.
Absolute value.
Ln of absolute value of x plus c, right? Now, a common mistake that students would make is that whenever they see 1 over anything, they think it's just ln of that thing. This is incorrect. That's not true. You have to have 1 over a linear function to get an ln. Or you have to be able to create something like that from a substitution to get an ln. So don't make that mistake. What are the mistakes? That's probably problem 5, because I think there were 6 things. Use parentheses appropriately. So this is more of a do, not a do not. So you're definitely going to want to use parentheses whenever they are required. So usually if you're like subtracting something, you know, you open parentheses after the minus sign, things of that sort. Or in general, this is just a smaller version of just use proper notation. Right? So if there should be parentheses, use them. Don't just say, in my head, I know there should be parentheses. Just, no, actually write it down. One of the little known things is that when it comes to learning math, it's really good to learn it as a language. So just like how with languages, there are grammar rules, and it just being able to communicate efficiently actually makes it easier to pick up the language. You have to know, if you know all the rules, you can construct the sentences and so on and so forth. Math is the same thing. The moment you have sloppy notation, your thinking is going to be sloppy. You're going to be messing up, and you're going to be working hard and messing up on things, and you're wondering why you're messing up on things. That also goes with the thing I was mentioning earlier about writing the entire rules. I can't tell you how many times I've seen people have like ln of x, like say the answer of something is ln2, like they're doing it, they got ln2 and then they just write 1/2 afterwards. And that's because they think that ln of x is 1/x, which is not true. I mean, what's missing here? The derivative, right? You see, the thing is, when they just think of it as ln x equals 1/x, you see, mistakes like this will slip in when they're not thinking about it. See, you can't actually jump from this line to that line. That's actually not true. ln of 2 is not 1/2. But because they don't remember the whole rule, they just have this equality in their minds with ln of x and 1/x, they end up making a mistake. And it just slips out, right? It's kind of like if you don't know a grammar rule, you'll inevitably say something wrong at some point. So with math, the language is important. The definitions are important, and knowing the language, how to write it down, very important. And people usually don't talk about that, but vocabulary, syntax, very important for mathematics, and you're doing yourself a disservice by not paying attention to it. Okay, I think that was it. I think that's it for this section. Yes, there were 6 of them. So, like I said, make sure you don't do any of these things, or else I'll give you 0. They are very serious offenses. Okay, what else? Okay, contact. When necessary, I'll contact you via the email you have on CUNY first. So whatever email you have on CUNY first currently, I actually have that loaded into a listserv, so I can send you emails. Let me actually send you guys an email right now. Hi. Click on the above and the phrase. It'll ask you to create a password. Test. Okay, so I just sent you an email from, it's Jupyter Grades. So that's what I use to actually collect your grades, to record your grades. So now, that's something that you can log in and see your grades I have to in real time. So as of now, the only grade that's up is the one for attendance. So you should see that everyone has like an A+ now. You just showed up and you have an A+, that's awesome. Yeah. So you'll either get emails from me, which is Jhevon Teaches at Gmail, or you might get emails from Jupyter Grades. Either case, it's important that you read the emails whenever I try to email you, because usually it's some sort of important announcement that I'm making. Okay, so everyone needs help sometimes. Don't feel ashamed if you need help. There are many resources here that you can get help. First of all, there's me during those office hours. And so, come talk to me. I'm here to help. I'd like to help you learn, help you succeed. I know I probably scared some people like, I'm going to give you 0, but really, come talk to me, ask me questions. I'll really help you out. And so, also, on the website, that's also going to be a helpful resources, because every time I give you a quiz or a test, I'm going to post a blank version of the quiz or the test on the website. I'll also post the solutions, so you can go back, retry, and then check your work with the solutions, and that might help you if you're talking to tutors or whatever. So the website, I'll post a lot of stuff. I'll post reviews for tests. The syllabus will be there. Link to the YouTube video will be on the website. Lots of stuff will be on the website. That makes it very useful, so that's good. You will also have free tutoring. So besides my office hours, if you can't catch me, free tutoring is in the Marshak building. It's a big, tall science building in 403. You can find out more information on that. I think they usually open like 12 to 5 every day. And they usually start about a week after classes start. So probably by next Monday they'll be open. That's another place. I used to work there, so I can tell you that the people there, they used to be good back when I was there. It's been a couple years, so I don't know. I think Andy's still there. Andy's still pretty good, so you can get help from him. Lots of other online resources, Wolfram Alpha, Symbol Lab, very great in checking your work. If you need graphs, graph.tk or desmos.com. Other maths help forums, Math Stack Exchange, Paul's Online Math Notes, or just your everyday friendly old Google search will do wonders. Your classmates are another good resources. So you probably should have the contact information of one other person. Say, hey, my name is so-and-so, let's exchange information so in case you want to study together or whatever. That can be a good resource if you use it properly. Right? Okay, Student Disabilities Office. So we do have a Disability Services Office here. In fact, it's on this floor. I think it's around the corner somewhere. So if you have a disability that you think might affect your academic performance and you should go talk to them to see what accommodations you may or may not be entitled to. In terms of class rules, the usual class rules, no cell phone use, no eating. Drinking is allowed as long as you remove your garbage. Academic integrity policy, don't cheat. If I catch you, I will fail you. That's pretty much it. Another blurb of advice here, believe in yourself. I mean, it sounds cheesy, but it's actually super important, actually. Like I can't tell you how many stories I had where literally just a mindset change changed this person's entire path. Like they were going for a D or an F, and literally like I gave them a pep talk like 2 weeks prior to that, and they end up with an A in the class, like literally just because of a mindset change. If you think of it as hard, if you think of it as, oh my God, this is impossible, I'm going to really fail this class, chances are you will fail the class. But if you're like, I can do it, I just keep you have to do it. You try something, it doesn't work, you go back, you try something else, you come talk to me, you get advice, you try something else, you keep trying and just believe that eventually you'll get it, and usually by the end of the semester you actually do get it. So yeah, pay attention, I'll give you advice throughout the semester, and just listen to my advice because it works. So, a few important dates from the academic calendar. These are just some snippets. The full academic calendar is found here. Things like when there are day changes is important. So you'll see, like, for example, Wednesday, February 12th, the college is closed. There's also on Tuesday, April 7th, the college follows the Wednesday schedule. Spring break happens on April 8th to April 16th, stuff like that. Final exams is this week. May 18th to 22nd, do not make travel plans for those times. So, last day to withdraw the class is April 1st, April Fool's Day. Just make sure you try all you can before that date so you have a really good idea of what you know versus what you don't know. By that point, you'll have a bunch of quizzes and one test graded, so you'll kind of know from a grading standpoint how you're doing. And these are the list of topics that we'll be covering throughout the semester. These are suggested exercises from the text. The ones in bold, although you can't really see some of that here, but the ones in bold are the ones where there are similar problems on your online homework, but the other ones are good practice either way. So these are the topics we'll be doing, as I said. You also now know the dates of test 1 and test 2. So there are going to be 2 tests. So test 1 will be on for you guys Wednesday, March 25th. The date is set in stone. The topics, I don't know, I might not cover everything, but the date is set in stone on Wednesday, March 25th, whatever we covered up to on that up to that point, I'm giving you a test on it. Then the second test will be on Wednesday, May 13th. That will cover everything that test 1 didn't cover. So whatever is left over, we will be getting tested on that date. The final exam schedule isn't finalized, but the moment it is, updates will be posted here, and I'll also let you guys know when the final exam will be. Chances are it'll be in this room, but that might also change. And the last page is a questionnaire. You guys can all fill out, then detach, and hand it in to me. While you guys are filling that out, there's a lot of talking, lots of information, but in the meantime, any questions, concerns? Yes?
I know this is way ahead of time, but in case we can't make the final, is it like an alternative date you can get to take the final?
No, like if you miss the final, there has to be a very good reason, and it's rescheduled by the math department.
Okay.
And you won't be able to take a makeup final until a few days before the start of the next semester. So like literally like 2 or 3 days before. So it makes it hard to plan your schedule, but it's only in cases of extreme emergency, so don't actually plan on missing the final. So it's only in case of emergencies, and I don't reschedule your final, the math department does. So I believe the people who missed the final last semester, they actually did the makeup final on Thursday last week or Friday. So they didn't really know if they were going to make it into this class until like last weekend. So you probably want to actually make sure you're here for the actual final, because making it up has their issues. Other questions? Yes.
What do you suggest is the best way to prepare for your quizzes and tests?
Well, quizzes are not cumulative. The quizzes usually cover all the things that I covered the week prior. So like I'll usually give you a quiz like every Monday, and that will cover what I covered on the previous Monday and Wednesday. In terms of how you want to study, first of all, you need to know the basic rules. So just like how here I listed like the product rule and some other rules, like you need to know the basic fundamental formulas. I tend to ask you about those first. Like, oh, just tell me what the formula for this is. Tell me what the formula for that is. Then I'll go into actually doing some examples. And if I tell you any strategies to do them, then I'll also probably ask you about the strategy. Do you know what the actual strategy is? What is the first step in this process? Things of that sort. Then I'll actually give you some examples. Then in the last section, I'll actually put some bonus problems usually. So the bonus problems cover things that I have yet to teach. So for anyone who's reading ahead, they can probably get some extra points from the bonus problems. So, but that tends to be the structure. So general formulas I'll ask you about first, maybe strategies I'll ask you about second if it is applicable. Then I'll have you do a few specific examples where you actually work something out. Then I'll ask you some bonus problems. And it'll all be like short answer, fill in the blank type stuff for quizzes. So for the test, I'll actually post a review and tell you specifically how to study for the test, so that I post on the website. But in terms of quizzes, that's kind of how you want to prepare. Know the general formulas and strategies first, then know how to actually compute examples. Yes?
You say you write the final for this class, right?
Yes. So any final that occurs at 6 p.m. or later, if the class starts at 6 p.m. or later, the teacher writes the final. If it's before that, the math department writes the final. You take a general review and the final. In either case, I would grade the final, but I'm not writing the final. So for you guys, I am writing the final, so that's a little, you have a little bit more control in your hands in that sense. So, other questions? That actually took a little bit longer than I wanted it to take, but I mean, if I can talk about some things here. So, one thing you would notice about the syllabus, if you go back to the topics page. So, like, it's really crammed to the point where you'll see even some of these omissions here. That's not even me. That's like the math department who says, okay, when you talk about this, omit that, omit this. They'll give you a bunch of omissions because we're going to learn a lot of things kind of crammed in here. So just to alleviate some of the pressure, there are some topics that, while technically they're in our syllabus, they're mostly actually a review, and I'm just going to skip them. So these topics are indicated by not done in class. So you'll see here, review of indefinite integrals, review of definite integrals. That's covered in the last 2 weeks of Calc 1. I expect you guys to be experts at that. I'm not actually going to cover that, so we're just going to actually skip those. Using basic integration formulas, again, I'm going to expect you to know that. If you don't know that, like I said, go back and you can watch lecture videos here, or just read the textbook and catch up on that on your own. So I expect you to be able to catch up on this on your own. By the way, these things where it's not done in class, that's what your homework is on. So you can know that if you remember anything, you try your homework to see, do I remember all these rules? Because you're going to need to know all the rules. There is another thing here. So yes, 7.1. I wrote that as not done in class, and I'll tell you some highlights from 7.1 probably. But I'm not going to cover that. So in 7.1, in 7.1, they talk about the logarithm as defined by an integral, where basically they define the natural logarithm in terms of an integral. They said ln x, our definition, this is short for definition. Our definition of the function ln x is going to be the integral of 1 over t dt from 1 up to x. And you might realize by the fundamental theorem of calculus, we can actually compute this integral. Integrate 1 over t, you get ln of absolute value of t, but because we're on the interval 1 to x, that's a positive interval, so the absolute value of t, you can drop it, you just get ln of t, and then you can plug in x minus ln of 1, which you get 0. You can also see that if you plug in 1 here, you integrate from 1 to 1, you also get 0, so ln of 1 is 0. So they pretty much made this definition, and you can derive this easily by the fundamental theorem of calculus, part 1 in your textbook. Although when I taught it in Calc 1, I sort of looked at this as part 2. You can realize that the derivative of this guy is the derivative of this guy, which is just going to be 1 over x by the fundamental theorem of calculus. So they define the logarithm this way, they derive the derivative for the logarithm that way, and then the section just goes through and it rederives all the rules that you already know about exponentials and logarithms, but it derives them from this perspective, that the logarithm is just a function that is defined by this integral. Now, personally, I don't really find that very helpful or intuitive. I much prefer the way that I introduce exponentials and logarithms in Calc 1, which again, you can watch and see how we actually did it. And I derived all the rules from scratch, all the derivative rules, I derived them from scratch. So we derived how to differentiate the exponential function. We use that to derive how to differentiate the log function. We use that to derive the power rule. We proved the chain rule, the product rule, the quotient rule. We proved everything. So in Calc 1, I really built up everything, and I really don't see the point of going over all that. This definition can be useful in some situations. You'll probably see some of those in Calc 3, maybe differential equations, and some other situations. It helps you to compute things easier sometimes. Sometimes you can have some integrals with ln in it, and you create a double integral using this formula, and it's easier. Don't worry about what double integrals are, that's the next class. So you can actually swap this out in some formulas, and it makes things work out nicer, but it's not very intuitive. Like, why would you think of this function as that? Like, I don't know. So they define that function, and they pretty much derive all the rules from that, and they also define the number e. E is the number so that if you integrate from 1 up to e of this thing, the answer is going to be 1. Which again, I think it's nicer to define e another way, and I did that in Calc 1. So they gave us these definitions. which they are useful in some contexts, but not any context that a Calc 1 or a Calc 2 student is going to really appreciate and actually use. So, yeah, I'm not really going to think of it that way. But they did that, but then they just go and derive all the rules that you already know about exponentials and logarithms. So I'm kind of just going to skip that section, essentially. And in terms of if you want to know, do I remember all the rules about exponentials and logarithms and how to do calculus with them and what their graph looks like and all that stuff, do the homework. The homework is going to tell you if you remember all that. So there is some homework on this stuff. But it's nothing new. It's just they derive all the rules that you know already from a different perspective. So we're kind of going to skip that. Anybody have time for that? Yeah. Other than that, all these not done in class, it's stuff that you did in Calc 1. Like you did this thoroughly in Calc 1. I'm not going to waste time on that again. I'd rather use that time to talk more about the 3D stuff, which might be difficult for some people to grasp. So yeah, not going to do that. Let's see here. Maybe I'll talk a little bit about hyperbolic functions. So it'd be nice if on Wednesday we can just start jumping straight into 8.2, which is integration by parts, a new integration technique. So let's actually get some of these topics out of the way. 7.3, hyperbolic functions. Now, we're going to talk about these functions, and I will give you a quiz on them next week. But after that, you can survive this class without ever actually invoking them ever again. They are just some tools that they're useful in certain situations. Again, if you're doing like complex analysis, they're going to be very useful. And yes, in Calc 1 and Calc 2, they are also useful, and I'll mention to you how they're useful, but you can also survive without them. Right? It's not something like, oh my God, you have to know about these functions or else you can't do anything. No, they're helpful in some situations, but you can survive without them, and it will just cause you a little minor inconvenience, but it's something that you should know about. You should know that these guys exist and they're a thing and we can use them in certain ways. So we're going to talk about those hyperbolic functions. Sometimes they're called hyperbolic trig functions because, as you will see, they function a lot like trig functions. In fact, the main functions here are the functions that we call cosh function and the function that we call sinh function. This is called a hyperbolic cosine. We read it as cosh. And this is the hyperbolic sine. And we read it as sinh. So we have two main functions, cosh and sinh. And they're very similar to they're actually similar to the cosine of x function and the sine of x function. What is the difference? So what is cosine and sine about? What are those guys? What is the point of the cosine function, the sine function? Huh?
Trigonometric cyclic functions.
Yeah, but where do they mean? Where were they developed? What is their definition? What are they? Like if I say cosine of x, what does that mean? So, there's the unit circle. Cosine and sine were just functions that we invented to subtract points on the unit circle. So you have the unit circle. If you create an angle with the origin, where it starts measuring from the positive x-axis going up, like say an angle theta, the cosine is the function that will give you the x-coordinate, and the sine is the function that will give you the y-coordinate of the line extending from the origin. Right? And the word trigonometry comes from triangle because we could actually create a right triangle using this idea, and we could derive a lot of rules from the trig functions using right triangles and Pythagoras' theorem and all that good stuff. So that was what the cosine and sine was. Someone just said, we want another way to represent points on the unit circle. And we're going to cover a topic called parametric equations, where you're going to see why something like that is super beneficial. Think of the x and y coordinates as something else. Think of a function that measures the x value and the y value separately. These are the cosine and sine, right? So that's what they did. The hyperbolic trig functions do something very similar. However, they do it with a hyperbola. So they do it with the unit hyperbola. So the unit circle, this is x squared plus y squared equals 1, which is why cosine squared plus sine squared equals 1. The unit hyperbola, this is x squared minus y squared equals 1. And that's the guy that looks like this. And in the same way, we try to measure functions that give us coordinates on this thing when an angle theta is made here, and cosh is the x coordinate of that, sinh is the y coordinate. Right? So they were developed using the same kind of principle. Here's a very important equation that we like. We want to be able to track the x and y coordinates separately. Cosine and sine does this on the unit circle. Hyperbolic cosine and sine does this on the unit hyperbola. That's why they're called the hyperbolic trig functions. Right? Now, it turns out that you can derive, we're not going to do it because it's actually slightly annoying, that the cosh is e to the x plus e to the minus x all over 2, and the sinh is e to the x minus e to the minus x all over 2. So for the uninitiated, anytime I put something in a box, that is something I expect you to remember, and chances are that will be something that will show up in problem 1 of a quiz. Like I said, I'll be doing this throughout the semester. I'm going to tell you exactly what I want you to know. I'm going to tell you, hey, I'm going to ask you a question about that, and I'm going to ask you a question about it. And then students are going to go, oh, the test was so surprising, I can't believe you put it. If you're paying attention, there will be no surprises. I'm going to tell you, I'm going to ask you about this. Everything I put in a box, expect me to ask you about it in problem 1 of a quiz the following week. Okay? So, you can actually derive these definitions. Now, that can give us some consequences here. Also, it can be derived that your sinh is odd. Not odd as in strange, I mean odd as in, if you take the sinh of a negative angle, it is the negative sinh of the angle. You can also realize that cosh is even, in the sense that cosh of a negative angle is the same as cosh of the positive angle. In fact, that's just like sine and cosine. Sine of negative x is minus sine x. Cosine of negative x is positive cosine of x. You can also derive the fact that cosh squared x minus sinh squared x is 1. Right? Now, we know that that had to work because that's the equation we're trying to model, x squared minus y squared, so it means a negative sign in the middle. But you can actually do this directly. If you square this, and then you subtract the square of that, it actually works out to 1. we're not going to do it because it's just a minor exercise in algebra. But that's something that's going to be very useful. You're going to realize that there are cases where when you have the sum of squares, you're going to think of sine and cosine, but when you have the difference of squares, you're going to think of hyperbolic sine and cosine. What else? Now, it's very rare that you need to know the graphs of these guys, but if you want to know the graph of cosh, it actually looks like a parabola, although it's very different from a parabola, where it's asymptotic to e to the x over 2. These should actually go through the origin. And e to the minus x over 2. When you add both of these together, you get the cosh, and it kind of sits on top of that. So it looks like a parabola, but it actually increases exponentially, right? So it actually grows a lot faster than any parabola. You can also realize that the sinh graph kind of looks like an x cubed, but it's very, very different from an x cubed. That one is actually asymptotic also to e to the x over 2, and on the bottom it's asymptotic to minus e to the minus x over 2. So it kind of hugs these curves as it goes off to infinity. So it looks like x cubed, but it actually increases and decreases a lot faster than x cubed. That's another thing I expect you guys to know. Exponentials grow a lot faster than polynomials. Logs grow a lot slower than polynomials. That sort of thing. So if you have like a limit as x goes to infinity of e to the x over x squared, I expect you to know that that's infinity. And if you flip it, x squared over e to the x, I expect you to know that that's 0. So exponentials grow a lot faster than polynomials. So these guys actually increase very fast and decreases very fast over here. It's actually increasing the whole way, but you know. So that's what the graphs would look like. You can also see we also have some definitions. We define a lot of other hyperbolic functions. So this guy we call the tanh, hyperbolic tangent. It's pronounced tanh. Hyperbolic tangent, and this is defined as the sinh over the cosh. We also define the hyperbolic secant. There's no diminutive for that. That's very, so it's just hyperbolic secant, that's 1 over cosh. Hyperbolic cosecant, 1 over sinh. Hyperbolic cotangent, 1 over tanh. And so then this guy, just like you have a list of Pythagorean identities, you can create them here as well. If I were to divide both sides here by cosh, you would get 1 minus tanh squared equals hyperbolic secant squared. So these are two very important formulas. So know the graphs, know the main definitions, you know those guys. Now, let's talk about their calculus. Like, why would these be useful to us? And I know I'm just blabbering on, but this really is just an information dump. There's not really much to understand at this point. I'm just kind of telling you how these work. This is the definition. Them's the rules. Calculus. Let's let's say you wanted to differentiate cosh. What would the derivative of cosh be? Well, this means you're differentiating e to the x plus e to the minus x over 2. And you know that if you're differentiating a fraction where the denominator is a constant, you just leave the denominator alone and differentiate the top. Derivative of e to the x is e to the x. Derivative of e to the minus x is minus e to the minus x. You'll notice that that is sinh. Derivative of cosh is sinh. Similarly, we can get a bunch of these rules. The derivative of sinh is cosh. The derivative of cosh is sinh, as I showed you here. The derivative of tanh is the hyperbolic secant squared. The derivative of secant is the derivative of hyperbolic cosecant. The derivative of hyperbolic cotangent. So already you see that it looks a lot like trig functions. However, there is no sign change for the cosh and the sinh derivative. So the derivative of positive cosh is positive sinh. So that's a little bit different, but sometimes those differences are actually pretty useful. For these guys though, for all the reciprocals, those guys all take negative signs, right? But other than that, they function, pardon the pun, very much like trig functions. So remember the derivative of secant x is secant x tangent x. It's pretty much the same here. Hyperbolic secant times hyperbolic tangent. So the derivative of cosecant x, you might remember, is minus cosecant x cotangent x. So this is also similar. And for this guy's cosecant x squared. Let's see here. Expect you to know this, expect you to know that. Now something that's also useful are their inverse functions. So we can take inverses of these functions, just like we can for trig functions. And this is pretty much to be continued. Because there are some things that we can do with hyperbolic functions here that you're not going to know today, but after I teach you some things in the future, I can come back and, go off on a tangent and tell you, oh, by the way, the hyperbolic trig function is this. Pardon the pun again, definitely intended. So let's say we can have inverses. So let's say I wanted to find, so sinh inverse x exists without restriction because it is a one-to-one and onto function, so the domain and range is all real numbers here. Cosh though, so we just take the positive side, so pretty much. If you look at the graph of cosh, it's not one-to-one because it doesn't pass the horizontal line test, so pretty much what you do is you just ignore the right side, so you look at ignore the left side, look at the right side, so it only works on the positive wing, and you can find the inverse of this graph. But that being said, here. If you wanted to find the derivative of, say, the cosh inverse, right? How would you do that? Well, what you can do is you can set y equals cosh inverse of x. This would mean that cosh of y equals x. This will mean that you can differentiate this side using the chain rule. What would you get?
Sinh y times y prime equals.
Right, y prime sinh y equals 1. So this means that your y prime here, the derivative of the guy we want, is actually 1 over sinh y. But you might remember that if I look at the cosine as a negative, the cosh as a negative, you remember that cosh squared minus sinh squared equals 1. So this means that the cosh, the sinh, because of how the cosh inverse works, we only care about the positive radical, so I can take the positive radical. Cosh squared minus 1. And so this here is going to be the positive radical. Cosh y minus 1 by applying that identity here. And this is just going to be cosh of y squared is actually just x. That's 1 over the radical of x squared minus 1. So, in other words, if I wanted to differentiate the inverse cosh, this is 1 over the radical of x squared minus 1. Now you'll of course notice that that's super similar to the derivative of sine inverse, right? Except for the sine inverse, you have 1 minus x squared. For the cosh inverse, you have x squared minus 1. So this is one of the reasons why a hyperbolic trig function might be useful in calculus. Sometimes you might have a situation where a trig function will work if only the signs were different, right? And a lot of times when you're in that situation, if only that negative sign was a positive sign, chances are there's a hyperbolic trig function that can fill that need. So while you don't have to have it, it comes in handy sometimes to just say, you know, if you want to integrate 1 over the radical of x squared minus 1, I'm going to actually teach you another way to integrate that. It's actually going to be super annoying. But another option you have is just, oh, that's just hyperbolic cosh inverse, the derivative. And that's a theme with the hyperbolic trig functions. A lot of the times, in the places where trig functions are useful, hyperbolic trig functions will be useful if the signs were just a little bit different. And when we get to series, you're going to see that as well. The series for the hyperbolic trig functions tend to be like the one for the trig functions, but without the alternating plus or minus sign. Don't worry about it if you don't know what I just said. We'll actually cover that in detail. So similarly, what's the right one to know? Similarly, the derivative of tangent inverse is going to be 1 over 1 minus x squared. So if you ever have the integral of 1 over 1 plus x squared, you can say, oh, that's the tan inverse x plus c. If you have the integral of 1 over 1 minus x squared, you can just, oh, that's just tangent inverse of x plus c. So that's another useful formula that shows up when you have 1 minus x squared instead of 1 plus x squared. I'm going to give an example. I mean, knowing the cinch might be useful. So, in terms of what you need to know about these functions, pretty much the formulas. These will be very convenient in certain situations. So know what the definition of their formulas are in terms of exponentials, and know how to differentiate them. And of course, as we learned from Calc 1, every time I tell you a derivative rule, I'm actually telling you an integral rule in reverse at the same time. Do you have a question? Huh?
Stretching.
Oh, stretching. And that's pretty much it. Let's look at these examples just to get your feet wet. Like I said, after next week, you probably never even have to remember these again. But you might find yourself in a situation where they'll be very useful to actually do. So just to get used to them, try these examples. Differentiate that. Differentiate that. So these aren't meant to be hard, they're just meant to get you used to the rules, as well as applying things like the product rule and the quotient rule, but having hyperbolic trig functions in play. F, find the integral of tanh. You'll realize that reminds you of another formula. Find the integral of e to the 2x over 1 minus e to the 4x. So that's one that you can't really do with Calc 1. Although we'll also learn a method where you can do that with without doing hyperbolic trig functions. But with what I've told you so far, you can actually do that integral. So try those for fun. We'll actually start next class by just running through these very quickly, but go home and actually try them on your own. But next class we're going to start integration by parts, which is going to be a lot of fun. So as you can see here, if this class were to break into parts, the first part is going to just be integration. We're going to learn a lot more integration rules. We're going to learn the fundamentals of integration. Then we're going to go into series, and we're going to see some ways how to use them, not so much application, but series are highly applicable. And I'll mention it, but we won't really do anything with it. Then we go into parametric curves and vectors, and then we go into some 3D stuff. That's going to be fun. Yeah, I just wanted to get 7.3 out of the way. Something you should be aware of, although you can get through math without ever even doing it, but should know about that. And with that said, we have just about enough time, and it's probably 2 minutes less than that, but for the next phase of the class, we will have our first quiz of the semester. So you can put away your stuff, and we're going to begin. Quiz every week. No time to slack off. So let's get this done. With that, you can, at the end, hand in your quiz as well as the questionnaire. So you probably leave your questionnaire on your desk, but other than that, not much. And see you guys Wednesday.